Hey guys, welcome. Today we are going to talk about solving systems of equations by elimination. Okay, so when we see this word elimination, we really should be thinking we're going to eliminate something from the equations. That's why we call it elimination. So we're trying to get something to go away completely. What that is it's one of the variables. We are going to try to eliminate a variable so we can solve for a variable and get our ordered pair that tells us where the systems would intersect with each other, because that's our solution, is where they intersect. So what I'm going to do is I'm going to kind of walk through and talk through these 6 steps on how to solve with elimination. Then we're going to do a couple practice problems together just so we feel comfortable. So step 1, it says that we want to make a variable, making sure you understand we're talking about a variable. That means something with a letter, an X or a Y. Make a variable in each equation the exact opposite. Okay, sometimes this is already done. Well, what do I mean exact opposite? For example, if we have the term 2x in one of our equations, that means the other equation, we would want it to have a negative 2x. Because if I combine those together, if I add them together, they eliminate each other. They give us 0. Okay, 2x plus a negative 2x is 0. Okay, so that's what I mean by exact opposite. Whatever the number is with the variable, they need to be the opposite sign. Okay? If it's already done, then you skip over number 2 and go straight to number 3. If it's not done, then we have to use step number 2 to help us get them to be opposites. So it says you may have to multiply an equation by a value to make a certain variable opposite in both equations. Okay, so that just means that if I don't have a piece from the first one and a piece from the second one that are exact opposites, we might have to multiply one of the equations. Sometimes we have to multiply both equations by a value, a number, in order to make them opposites. Once we do this, then we can combine the 2 equations. Okay, when I say combine, I mean add them together. When we add them together, that's what eliminates the term that were exact opposite. Okay, so step 3 is really where the elimination takes place. Once we've done that and we've combined them together, we're going to notice that we only have one variable left. So all we're going to do is solve for the variable. Okay, this is going to give us the first part of our answer. So I'm going to write this the first part of the solution. Okay. Once we get that first part of the solution, just like when we did solving a systems by substitution, we are going to take that solution and plug it back into one of the originals. So step 5 says we're going to substitute this variable, so from number 4, into either of the original equations and solve for the second variable. That's the second part of our solution. And then the last step is to make sure that we write our solution as an ordered pair. Okay? Remember, with a system of equations, the solution is where they intersect on a graph. So that means we need to have a point, an X and a Y. Okay? Always write the X first, and then we write the Y. Okay? So now that we've kind of talked through those steps, now we're actually going to look at an example and see how do we actually solve this problem. So number 1, we have the system that says 4x minus y equals 1, and then negative 2x plus y equals 3. So it's a systems because there's more than one equation, and we want to find where they intersect each other. Okay? Well, what we want to do is we want to look at step 1, which says make a variable in each equation the exact opposite. So if we look at the variable x, we have a 4x and a negative 2x. Those are not opposites. If it was a 4x and a negative 4x, then that would be exact opposites. Okay, so let's look at the y's. I have a negative y and a positive y. Those are exact opposites. So that means we already have that part done. So we can skip down to step 3. We don't need to do step 2 because they already are opposite. Step 3 says we are going to combine the two equations. That means add them together. So put a big old plus sign on the left-hand side and draw a line. Now, when you go to add them together, we need to make sure that the pieces are lined up correctly. So notice that the x piece comes first, then the y piece, then we have our equal sign, and then our constant at the end. We need to make sure both equations are in that same order so we can combine them. Okay? If they're not, then we'll have to reorder them, and we'll see that in one of the examples later. All right, so we're going to add, say, 4x plus negative 2x. That's 2x. Negative y plus y, so we're adding vertically. Okay? Negative y plus y, that eliminates. It gives us 0. It cancels. Then we have our equal sign, and 1 plus 3 is 4. Now we're on step 4, which says solve for the variable. Well, our variable here is x. So to solve for x, we divide by 2, and x is going to be 2. So like I said, this gives us the first part of our solution. So our solution's an ordered pair, and the number 2 is the x of the ordered pair. Now what we're going to do is we're going to find the other part. So step 5 says we're going to take that x equals 2 and substitute it back into one of our original equations. It doesn't matter which one you pick, so I'm just going to use the top equation. 4 times 2 minus y equals 1. So notice we should be solving for the y because that's the piece that's missing. So this is 8 minus y equals 1. Okay. If we move the 8 to the other side with subtraction, we get negative y equals negative 7. Got to get rid of the negative, so divide by that negative 1. And the y we get, well, negative 7 divided by 7, or sorry, negative 7 divided by negative 1 is a positive 7. So that means our solution is 2, 7. Yes, you guys have to write your solution as an ordered pair. Don't just leave the x equals 2 and the y equals 7. You've got to write the ordered pair. Okay, so now let's look at example 2. Okay, first notice that they are both in the same order, the x variable, the y variable, then the equal sign, and then our constant, so our piece with no variable. Okay. Now I want to look and see, are any of these, are the x's already exact opposites, are the y's already exact opposites? So if we look at the x's, we see that they're the exact same. So that's pretty close to being opposite, okay? Except I need one of them to be negative. Okay, so, oops, sorry. So what we want to do is I want these 6x to stay a 6x, but the one on the bottom, we want to change it to a negative 6x. So if you look at step 2, it says you may need to multiply by an equation by a value. Well, what can we multiply 6x by to make it a negative 6x? Well, we can multiply by negative 1. So we want to take the whole bottom equation. Here's the part you have to remember. The whole bottom equation, and we're going to multiply every single piece of that by a negative 1. All right, so what I'm going to do is I'm going to rewrite my equation first. So I'm going to take the top equation, 6x plus 2y equals 4. I just rewrote that one. Now I'm going to take the bottom equation and I'm going to distribute that negative 1 to all three pieces. So negative 1 times 6x is negative 6x. Negative 1 times y is negative y. Then there's my equal sign. And then negative 1 times negative 4 is a positive 4. Now we can combine them together, so I'm going to add these up. Well, 6x plus a negative 6x eliminates, and it's gone. 2y plus a negative y is just y, and 4 plus 4 is 8. So here we see that the y part of our solution is 8. Now we need to go and find the x. So we're going to take that 8 and plug it in for the y in one of the equations. It does not matter which one you choose, so I'm just going to choose the top one. Okay, so I'm going to do 6x plus 2 times 8 equals 4. So 6x plus 16 equals 4. All we're doing here is solving for x, so subtracting 16 on both sides. 6x equals negative 12. And then divide by a 6, and x is going to be negative 2. So that means that is the x of the ordered pair, negative 2. So the solution is negative 2, 8. Okay, so let's go on and let's look at this next one. So this next one is a special one. Okay, first off, my equations, if you look at them, they are not in the same order. I like to have the x and the y on one side and the constant on the other side. So if we look at this second equation, we're going to need to move the y to the other side. So first off, if we subtract y from both sides, this is my new equation. Now we need to ask ourselves, do I have exact opposites? Well, I have a negative 10x and an x. I have a 10y and a negative y. Okay? Again, I'm only looking at the pieces with the variables. Okay? So for this one, let's just do the x. How will I make negative 10x have an exact opposite with the x? Okay? Well, I'm not going to multiply the negative 10x by something. I want to multiply the second equation by a 10. We multiply the second equation by a 10, my x piece will now be a positive 10x. Right? So the first thing I'm going to do is rewrite. Negative 10x plus 10y equals negative 10. This is the first equation. Now my second equation, when I distribute, is going to be 10x minus 10y equals 40. Okay? We're at the point where we can combine. Well, notice what happens. Negative 10x plus 10x goes to 0. Oh, what happens with our y's? 10y minus 10y also goes to 0. So on the left-hand side, we have nothing left. We have 0. On the right-hand side, we have 30. My question is 0 equal to 30? No, it's not. It never is. So the solution for this would be no solution. There is no ordered pair that you can come up with where these two lines would intersect. That means that these lines are parallel. Okay, and if you remember what parallel lines are, they're two lines that run next to each other and never ever intersect. Okay? So that's one of our special cases. You'll want to make sure that you understand that if you get something like 0 equals 30, that means there is no solution. There will never be an ordered pair where these two intersect. All right, we're going to take a short little break, come back in the next video to see the next 3 examples.